All right, so our first section, as you can see on the sheet, this is my favorite of the units that we go through, because this is what I majored in college. When I got my degree in math, I majored in set theory. Who knew there was such a thing? So I get pretty excited when we get to go into chapter 2, and in section 2.1, we're just going to talk about basic set concepts. So a lot of what we talk about today is just going to be the terminology that we use when we're talking about sets, so that we can speak to each other in good ways about it. And then when we come back next week, we're going to talk about things we can do with sets and relationships. And then the way this unit ends is a nice, simple kind of application of sets, so you can kind of get an idea of where in the real world you might see or use some of these concepts. So a set is not a super complicated thing. A set is just a collection of objects. So set's just a collection of objects. It can be numbers, it can be letters, it can be whatever, really anything you can throw together and call it a set. These objects that we put together in the set, the objects are called members or elements of the set. So if I use those words, they're interchangeable. Neither one of them is better than the other. If I use the word members of a set or elements of the set, it's referring to the same thing. So on your sheet, I've given a few examples of different sets, and I've labeled them. I'm just going to write them on the board because I'm going to interact with them. We're going to talk about some different things about them. So I just kept them kind of simple and small sets. There's nothing super special about each of these. Set A is the numbers 1 through 5. The set B, I think, is some shapes. We've got a triangle and a circle and a square. It took me forever to find those on Word. Set C is the set of days of the week. And then finally, the set D is the set of the best ice cream flavors. I find vanilla exciting, so deal with it. Okay, so those are the sets we're going to use to just talk about some different things and identify some characteristics of sets. Again, there's nothing special. There's no secret mysteries about any of those. They're just all easy to kind of work with and deal with. So set A and B, you notice both of these things, all the elements are listed out. You can see exactly what the elements are. These two sets are in what's called a roster form. For us in this class, that's going to be the most popular way to write down our sets, is roster form. Everything's going to be listed out. Set C and D, now this is a little less mathematical. This is kind of, to be honest with you, just a little bit of a shortcut to be able to write sets down. These two sets are in descriptive form. Basically, within the squigglies, the set brackets, you're just writing a little description. It's kind of the lazy mathematician's way to write down the sets that might have a whole bunch of different objects in them. So right away, one thing we can do when we have sets is we can talk about whether a set is what's called well-defined or not. And so a set is called well-defined if the elements are not subject to opinion. Meaning everybody's going to have the same set. Okay? Well-defined means that whoever you show the set to is going to say the same thing. So looking at the four sets that I've given you right up front, which one of them is not well-defined? Yeah, D. D is not a well-defined set. A, these are all going to be the same. These are all going to be the same thing, no matter who we talk to. Okay, but D, the best ice cream flavors, right there, that's what tells you that that's not going to be well-defined. So if you're labeling these things, A through C, these are what's called well-defined sets. And then D, this is not well-defined. I'm just cruising through. I'm having a great time. But if you have a question, if I've lost you on something, please just raise your hand. Let me know so that I can do a better job. I've got a brief little exercise right below. This is for you. I'm going to give you 30 seconds. There's 2 sets right there. I want you to label each of them as well-defined or not well-defined. All right. Academy Award winners in 2018. Is that a well-defined or not well-defined? It's well-defined. Whether or not you're interested in such things, a quick Google search is going to turn up the same results for any of us. So this is a well-defined set. The most interesting professors at Polk State, is this well-defined or not well-defined? Now, well, even though the Perkster would be in everybody's set, I am sure, but everybody, all the other professors, you would have different opinions on. So this one is not well-defined. It just depends on what you love, or maybe you have an empty set because you don't find anybody interesting, and that's valid concern too. Okay, great. So far, so good. That's kind of the first thing about sets that I wanted to mention to you, is what it means for one to be well-defined or not. Okay. Do a little reset here. Next thing, a set is called finite. That's a fun word. A set is called finite if it has no elements or the number of elements is a natural number. So it's called finite if it has no elements or the number Now, if you don't know what the natural numbers are, you'll know in about 4 minutes. Okay, that's one of the things that I'll mention. There was no way, if I talked about natural numbers first, and there was something about them that I would have been talking about before talking about finite. So there was no really great order. So I'll tell you what natural numbers are in a minute. Another thing about sets is something called the cardinality. The cardinality of a set is the number of elements that are in it. The cardinality of a set So the cardinality is just a fancy word for count up how many elements there are in it. And if you can come up with a number, then it is a finite set. So all 4 of those sets right there are finite sets. You're going to stop counting at some point. I want to show you the notation for cardinality because this is sometimes one of the most missed problems on the first test. Okay, so I want you to remember this notation because there's going to be at least 2 problems that I ask you this simple question. So when I want to know the cardinality, when I want to know the number of elements in the set, it's going to look like this. So here's my set A. A is 1, 2, 3, 4, 5. So then I can ask you, what's the cardinality? I can say that n, lowercase n, and then in parentheses, I put what the set is. So this says the number of elements in A, meaning what's the cardinality of A. So just remember that notation. Okay, you're going to interact with that. It will be on your homework. If you remember that notation, you're going to get at least 2 problems on the test, 100% correct. So what are we going to answer? What are the number of elements in set A? 5. Yes. So this is part of the exercise that's right below. So I asked you to do the same thing for B and C. So I'm going to give you 20 seconds if you can write down the answer to the next 2 problems. All right, so what did you write down for n of b, the number of elements in b? 3, great. And then I'm just going to write it over here because I'm kind of out of room on the video screen. What's the number of elements in C? 7. Yes, great. So far, so good? We still doing okay? Anything confounding or confusing? Please let me know. Yes?
So for that, we'll define your number set.
So if it's not well defined, you could, but you would have to write down, and since that's going to be different for everybody, then everybody would have a different cardinality of that one. That's why I didn't ask it. Okay, so if I was going to ask, I would do something like, what is your set D? What are the best ice cream flavors? And you would make your list. And then I would say, okay, now what's the cardinality of D? Okay, but since all of our sets would be different, I didn't think it would be a fair question to ask. Okay, great question, appreciate it. Anything else? Okay, well then there's an exercise right below. It'll take you 10 seconds to do. I've defined a set D. I just want you to identify what the cardinality of D is. So one final time, what's the answer to this? Great job. So continuing on, I promised you that I would let you know what these are. The natural numbers. You're probably super familiar with these. I'm guessing when you were in high school, you took at least one algebra class. I think it's required. And in algebra, if you took introductory algebra, one of the first things you do is you define the sets of numbers that you're doing algebra on. And one of the first sets you see is the natural numbers. For natural numbers, we use a nice uppercase N. Usually, if I have the ability, I would bold it. But since I don't really have that ability, I'm just going to do a nice capital N. And the natural numbers go like this. The reason they're called the natural numbers is they're probably the first set of numbers people use because use your fingers to count. So it starts with the number 1, and then number 2, number 3, number 4, number 5, and it continues following that pattern. You just keep adding 1. Now, this is a large set, it's an infinite set because you never stop counting, and I don't have the time to write down an infinite number of numbers. So what I'm going to do is I'm going to write 3 dots right here. Anybody know what this 3 dots means? Yeah, it just means to keep following this pattern. Okay, so instead of writing down 6, 7, 8, 9, 10, 11, 12, 13, and on and on and on, I write this thing, and this 3 dots is called an ellipsis. In case you didn't know that that had a name. Okay, that's from English class. So we've got our ellipsis, and the ellipsis means, if you're writing these things down, ellipsis just means keep following this pattern. So the number 35 would be a natural number because it would occur as part of this pattern. Notice in my natural numbers, there's no decimals, there's no fractions, there's no negatives, there's no 0. Okay, the natural numbers start at 1. All those other numbers I just mentioned, they are parts of different sets of numbers, and they're not going to be something that we do too much consideration in this class. So here's what I would like you to do. Or actually, I'm going to do this one with you. The next exercise says write the set of natural numbers less than 10 in roster form. Okay, so exercise. Okay. I told you what roster form was earlier, but I've erased it. So remind me, what does it mean to write a set in roster form? You list it out. Yes, exactly. And so we're writing the natural numbers in roster form that are less than 10. So where's my set going to start? At 1, because that's where the natural numbers start. And what does it mean to be less than 10? Up to 9, right? Just to make sure that we're reading the details, if I wanted to include 10 in that, what would I say? Instead of saying less than 10, I would say what? You could say less than 11, great. I wasn't even thinking that, so perfect. That's either sometimes there's different points of view, less than 11, but if I wanted to keep the number 10 there, I could say less than or equal to 10, okay? So I could use that relationship as well. So great call there. I appreciate you saying that, less than 11. So here's what I would like you to do. The next exercise, top of the next page, it says write the set of natural numbers between 3 and 12 in roster form. So if you would make your best hypothesis on what that is, I would love it. Again, just making sure that you're reading the details here. And remember, if you get something wrong when we're doing an exercise, don't beat yourself up. Okay, don't get all ashamed. That's an opportunity to learn. That's why we do things. Otherwise, why bother? Okay, so if I say between 3 and 12, what's the first element of my set going to be? 4. Okay. Then 5, and then 6, and then 7, and then 8. Where am I going to end? Great job. So I'm sure at least one person here is thinking, well, okay, what if I wanted to include 3 and 12, and I didn't want to say between 2 and 13, like somebody clever here would say. Well, the next exercise answers that. What's the one word that's different in the next exercise as opposed to the one that we just saw? Inclusive. Yes. So the word inclusive means, when you see it, it means include those endpoints. So that next exercise right there that says write down the set of natural numbers between 3 and 12 inclusive. Well, what that's going to look like is this right here. You're going to start with 3 now. And then you're going to stop at 12. So if you have a mind to, what I would encourage you to do is circle or highlight that word inclusive. It's important. It has meaning, and it tells you to do something a little bit different. Okay, and you're going to see that on the homework, and you might just see that on the test. Okay, either one or the other. So just make sure you remember what the word inclusive means. Okay, I just want to pause. We doing okay still? All right. Well, that's good. Glad we're feeling pretty good. Okay, so I've told you roster form is just listing out everything. And then the lazy mathematician's way is the descriptive form. But there's another way to write sets. This is actually very handy mathematically. We'll use it just a little bit in here. If we were going deeper into sets, and in the next section when we talk logic, we would probably go even deeper into this next way to write sets. But what we're going to talk about here is what's called set builder notation. And so I've given you kind of the shorthand there on the page. I've written this down. Okay, this is a very general expression of set builder notation. So notice we still have our squigglies for the set. So if you're reading this, you would say, okay, when you see this first squiggly, you would say this is the set. Now in this class, because again, we're not going super deep, we're just doing a real fast flyover of sets. This will always be what you see here. This right here is just saying this is the set of elements. Now, if we were in a different class, in a different context, the elements can take on different forms. I might show you something, I might just mention it when we come back next week and we talk about operations on sets, just to show you what can be done here, but it's not, as far as what I'm going to test you on, it's not something you have to focus on. You can always just put an X there. This little wall right here, when you're reading it, so we have the set of elements. This wall is read such that. And so then here's the important part of set builder notation for you. They then after this little wall, you say, okay, what are the conditions that make up the elements of my set? So this is going to be the part that I am looking to see if you have some retention on. So because of that, we're going to have a few problems, but I have one more thing I have to tell you about before we can do those examples and exercises that are right below. If I want to tell somebody that a particular element is part of a set, there is a nice symbol that we use. And so it is this right here. It looks like an E with the corners shaved off. This right here. So the next blank on your page, this symbol represents is an element of. Math people have a symbol for everything. So the way we would use this is we would say, okay, if I want to tell somebody that 2 is an element of that set right there, then I would say 2 with this symbol, the E with the corner shaved off, is an element of A. I erased the other ones, but if I wanted to tell somebody, I could say the triangle was an element of B. I could say something like Monday was an element of C. And just real quick, because I want to just make sure that you're comfortable writing it down, I just want you to write down that 4 is an element of A. Write down somewhere on the page what it would look like to write 4 is an element of A. And what I'm hoping you wrote down, and if you didn't, let's talk about it. What I'm hoping you wrote down is 4, just the number 4 is an element of A. Now you might say, well, can I tell somebody if something's not an element? Yes, you can. I'm glad you asked that question. So the number 9 is not an element of this set right here. So what I would do is I would say 9, and then I use the element symbol, but just like in arithmetic, when something's not equal, you throw a little line through it. So 9 is not an element of A. So there's how my language works when I'm talking about whether something is an element or not an element. And I mention that because we're going to need it to write down our conditions in set builder notation. So here's what we're going to do. The first example is my example that I'm going to do with you, and then I'm going to give you a bunch of opportunities to do the same thing because, in my opinion, this is probably the hardest thing we do today in our first day. So again, if you have a question, don't be shy. Don't leave here with the question. We've got plenty of time. So the first example says what we're going to do is we're going to write down the set of natural numbers less than 100. That pen doesn't work too great. Let's see. Let's try this one. So this is on your page. We're going to write in set builder notation the set of natural numbers less than 100. You might say, well, hey, Kirkster, why don't I just write that in roster form? We could, but it would just be an endurance exercise. Okay, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 99. And I'm not here to waste your time. I just want you to learn a little bit and hopefully enjoy. So we're going to use set builder notation. So here we go. The first little bit of set builder notation, like I've said, you can write with confidence this part down. So it's going to be the set of values x such that now I have to write down my conditions. And there are 2 conditions that I have given you in this little exercise. Can anybody identify one of the conditions? What is true about these numbers? There's 2 things these numbers have to be. They got to be less than 100, and they also have to be a natural number. Okay, fantastic. So here we go. I'm going to write down both of these things. First, I'm going to show you how do I tell somebody that my numbers are natural numbers. Well, they have to be a part, oh, I erased it, but it's still on your page. They have to be part of that set n, the natural numbers. So here we go. That's why I taught you about this cute little symbol right here. So we have the set of values x such that each value x is an element of the natural numbers. So x is an element of the natural numbers. And if you need to on your notes, because I understand that you might just be learning this for the first time and short-term memory by the time you get to your homework, just draw a little arrow and say, this is how I say that X is a natural number. Okay, that's exactly what this is saying, just in fun math symbols. Okay, X is a natural number. Then I'm going to write a comma. And then the other condition you told me I have to say is not only is it a natural number, it has to be less than 100. So I'm going to say, okay, X is less than 100. And there we go. There's my set builder notation. This is the set of values X such that X is a natural number. It's an element of N, and X is less than 100. Now again, I know that's something new and different and weird. So the next exercise is yours. It's super similar. I've just changed the number so that you get to write things down, because being tactile helps things go from short-term memory to long-term memory. So write the set of natural numbers less than or equal to 35 in set builder notation. So again, there's two conditions, and you can underline them or circle them, whatever helps you remember what they are. It's the set of natural numbers, so I'm going to stop there. So I'm going to indicate that it's a natural number, and I'm hoping what you wrote down is X is an element of N, comma, and then X is less than or equal to 35. Now, there's two things I would give credit for on the test. Okay, so I'm going to be literal and just write it down the way it is there. I'm going to write X is less than or equal to 35. But if you were somebody who wrote X is less than 36, that's fully the same thing, okay, as far as the natural numbers are concerned, because in the set of natural numbers, there's nothing between 35 and 36. If we were talking about if we're talking about rational numbers with decimals, these would not be the same thing, and one of them would be wrong. Okay, so, but because we're dealing with natural numbers, we have a little more liberty there. Okay, if you have a question, let me know. I'm just moving on. I'm going to do another example with you just to show you another thing you might be asked to do. The next one says, write the set of natural numbers between 5 and 50 in set builder notation. Okay, so the next exercise, the set of natural numbers between 5 and 50. Okay. Well, it's the set of values X such that, again, similar conditions. The first one, X is a natural number. I'm hoping you get used to writing that down. This is important. If you don't write this down, then you're making a much bigger set of a lot of other numbers. Now, if I want to write that my values are between 5 and 50, this is how we do this in arithmetic. I'm going to leave a little space. I'm going to write my X right here. Now, is there an inclusive there? Am I including the 5 and the 50? No, there's no word inclusive, so just make sure you're reading careful. So between 5 and 50 means that it's going to be greater than 5. Notice you always read from the vantage point of the X. So when I'm reading this way, X is greater than 5. And then when I go this way, it's got to be less than 50. There's my conditions. Do the next exercise, please. It's very similar. The set of natural numbers between 2 and 25. Okay, so it's the set of natural numbers between 2 and 25. I'm not including the endpoints. So it's the set of values X such that X is a natural number once again. and then it's between 2 and 25, so the x's have to be strictly bigger than 2, and then strictly less than 25, and there is my set of values. Give your best shot to the next exercise, and if you have a question about that one, don't let me rush by it. The set of natural numbers between 10 and 99, inclusive. Okay, so I've added the word inclusive in here, so it just changes things just a touch. Okay, so this next exercise. So the numbers between 10 and 99 inclusive, so it's the set of values x such that, again, x is a natural number, good, that's a given. And then now, since I'm including those endpoints, I'm going to do bigger than or equal to 10, and then less than or equal to 99, and that includes all my values. Again, the alternative is true. I'm going to leave this one because that's what it's literally saying. If you put x has to be strictly bigger than 9 and strictly less than 100, that would also be an equivalent form. Just making sure that you're able to read these things backwards. So the next exercise gives you a set that's in set builder notation and asks you to list it in roster form, please. Okay, so the two conditions, x is a natural number, that's good news. That means I can write things down, and then x is less than 9. So where does this set start? And then since it's less than 9, it goes all the way to 8. Perfect, great job. Please do the next one. Same sort of thing. You're taking the set that's given in set builder notation and writing it in roster form. So this one, where's this one going to start? And it's going to go all the way up to? Outstanding. The next one is a little bit of a challenge problem. Okay, I've given you a set. It's an infinite set this time. Okay, so write the set 5, 10, 15, 20, 25, 30, 35, etc. in set builder notation. Give it your best shot. Remember, if you get it wrong, you don't quite get it, it's okay. This is a challenge problem. Your description might look a little less mathematical, like the other ones have used the greater than symbol things. You might just be a little more descriptive in this. All right, so set builder notation. It's a set of values x such that, again, there's two characteristics of this. The first characteristic is all of these numbers, well, you can tell me either one. All of these numbers are what? Okay, they're natural numbers, great. That's kind of been a constant. What's also true about each of these numbers? They're multiples of 5 or divisible by 5. Yes, so then all you're going to say is something like that. So x is a natural number and x is a multiple of 5. There you go. Yes, challenge problem. So again, don't beat yourself up. It's okay. I knew that would be a fun one. There is a more mathematical way to say that, but we don't necessarily have the tools. So we're gonna, if you're super interested, the way you would say something is divisible is you would say 5 divides into a number. That's the mathematical way to say 5 divides into something, but you don't need more notation. You've had plenty today, so that's why I didn't feel like mentioning it. Okay. So, all right, we're almost done. You're doing a great job. I appreciate it. You're still all awake. No one is passed out from boredom just yet, so that's good news. All right, so the next thing is if two sets have the exact same elements, two sets have the exact same elements, they are called equal sets. The symbol for equals is just what you would expect it to be. It's the same as math. You're just going to use an equal sign. Okay, it's no different for sets as it is for arithmetic. So I have 4 examples. I'm going to write down real quick on the board. There's 2 at the bottom of page 2. There's 2 at the top of page 3. So the first one is I've got ABC and then BCA. The next one is ABC and 1, 2, 3. You don't have to write these down. They're all written down for you, but I want to make sure that we can do these things together. The next thing is 1, 2, 3 and 1, 1, 2, 3, 3, 3. And then last but not least, I've got A, B, C, D, and I've got ABC. So I'm going to leave it to you to make a hypothesis. I have defined equal sets to be sets that have the exact same elements. So what I want you to do is I want you, for each of these 4, I want you to put an equal or a not equal between them. Okay, equal or not equal between them. And there's one that might surprise you, but we'll see. Yes, of course. Just for future reference, you never have to ask me that. Okay, please freely do what you need to do. But I appreciate you asking. Different teachers have different thoughts on that. So, all right. This first one, what did you write down? Are they equal or are they not equal? They got the same exact elements, right? This is just saying that the order of the elements doesn't matter. Okay, so these 2 things are equal. They have the same exact elements. We good so far? Okay. How about this one? Are these equal or not equal? No. They're clearly not equal. They're completely different elements. So I'm going to put a not equal sign between them. This is the one that I think might surprise you. Maybe it won't. Do you think these 2 are equal or not equal? They're equal. They have the exact same elements. I didn't say anything about how many of them there were. I just said they're the same ones. And we've got 1s, we've got 2s, we've got 3s. There's nothing else. So these are equal sets. And last but not least, are these 2 equal or not equal? Why are they not equal? This one has a D. This one does not have the D. So they are different sets. Great. Well done. Any question about that? I got one more term for you, and then there's just one more problem that kind of summarizes everything that we've done. So we are approaching the finish line. Again, if you have anything we need to talk about in more detail, please let me know. The last thing today is what's called the equivalence of sets. And so if 2 sets have the same cardinality, meaning they have the same number of elements, they are called equivalent. Okay, so equivalent sets have the same cardinality. So for us, there's a couple different symbols you could use for this, but for us in this class, we are gonna, when something's equivalent, we are going to use an equal sign with 3 bars. Okay, 3 bars means equivalent, meaning they have the same number of elements. Did I say anything about what those elements are? No, they just have the same cardinality. So what I would like you to do, please, is for the same 4 problems, they're again listed on your sheet, write down whether you think they're equivalent or not equivalent. And for not equivalent, you would just put a slash through it like the not equals. So equivalent or not equivalent. All right, equivalent sets have the same cardinality. So here we go. These first 2 sets, are they equivalent or not equivalent? What's the cardinality of each of them? 3. Great. Next 2 sets, are they equivalent or not equivalent? Cardinality is 3, right? Again, it doesn't matter what the elements are, they just have the same number of elements. The next one, now remember, last time these were equal because they have the same elements. Are they equivalent? No, because this one, how many elements does this one have? 6. This one has 3, so they are not equivalent. I'm going to put a little slash through it. And then last but not least, are these 2 equivalent or not equivalent? Not equivalent, because one of them has 4, one of them has 3. Fantastic. All right, the last thing is I've given one more exercise. This is just a summary exercise of some of the things that we've talked about. So there's a set E there, and I've got 5 questions. One of them is a little tricky. Remember, if you get it wrong, don't worry, we'll talk about it. All right. Problem A. Is this set finite or infinite? Finite. Finite means that I can associate some natural number with it. So great. What is this? What does this mean? What's the cardinality? What's the cardinality of this set right here? What does this symbol right here mean? Is C an element of E? There it is. Is Z an element of E? Don't see it. This last one's the one that may surprise you. Maybe it's not. It's sort of a little bit of, I wouldn't call it a trick, but when we come back next week, we're going to talk about a relationship between sets, and then this one will be true. Is this? So element of means whatever you see here is in the set over there. Is this thing right here in the set over there? I'm covering up. Is this in the set? Is this in the set? No, the squigglies are not. So this is no. So the way that I could make that true, okay, is if the set here originally said, you don't have to write this down. I'm just showing you what the difference would be. If set E was A, B, and then C like that, now it would be yes, because I've got the squigglies, I got the whole structure. So the reason I point this out is just to prepare us for next week. When you use the element symbol, you're saying whatever this is can be found within the squigglies of the set. And the original set, before I changed it, that was a no. Yes?
So would, like going back to C, where if there was, like,
Okay, so with this being the set, is that what you're saying? I've changed it?
yeah.
Okay, so if this was the given set with the squigglies around the C, now this will be a no, because now it has the squigglies around it. So it all goes together. Okay, great question. I'm gonna stop the recording. Don't you can pack up, but I gotta call the roll.